Welcome to part 1 of case study ex4, where we'll show how to apply Java structured concurrency mechanisms. Case study ex4 compares and contrasts the programming models and performance results of Java parallel streams, completable futures, Project Reactor, RxJava, and several Java concurrency mechanisms that are applying structured concurrency to download, transform, and store many images from a remote web server. Part 1 of this case study is going to focus on the Java structured concurrency implementations. You can find these implementations in the ex4 project in my Loom directory in my Live Lessons GitHub repository. So we're now in my ex4 project in my Live Lessons repository, and let's go ahead and take a look at the code there. Let's take a look at the main entry point, which starts by parsing the command line arguments, if any, and then running a bunch of tests. We're going to focus on running the structured concurrency test, which we warm up first, and then we're going to go ahead and run the hybrid structured concurrency test for this part 1 example after first warming it up. And let's take a look at what run test does, and then we'll take a look at the implementations of the structured concurrency strategies. So the first thing we do is we go ahead and let the system garbage collect to ensure pristine memory conditions for the test. If the test contains the word warmup in it, we just run the test but don't record the time. But if it doesn't include the word warmup in it, we run the tests and stash the results into the concurrent hash map that's lurking inside this test implementation. You can see here that when we're done, we delete any images that we had, setting it up for the next go round. Let's now go take a look at the structured concurrency test to start things off. This particular test is going to download, transform, and store image objects using the Java structured concurrency framework. This particular example uses the Java 19 structured task scope shutdown on failure fork factor method, which creates a new virtual thread for each task. This particular implementation only applies Java 7 features. It doesn't use any of the modern Java features, which to some extent seems keeping a bit more in the spirit of what structured concurrency is about. So let's go ahead and take a look here. Here's the run method, which is the entry point into the structured concurrency test. And the first thing we're going to do is we're going to call a helper method called download images, which is going to take a list of URLs that I have provided from my website, and it's going to call download images to obtain a list of futures to image objects that will hold futures to the downloaded images, which will complete, which actually will have completed by the time this method returns, as we'll see in a moment. So let's go ahead and take a look at download images implementation. You can see here that it takes the URL list as a parameter, and then it uses this try with resources feature in Java, and it declares a variable or a resource in the try with resources portion, which is going to be a scope object, which is of type structured task scope shutdown on failure. So we make a new structured task scope shutdown on failure object. In order for this to work, by the way, you need to pass certain parameters to the compiler, first telling it to enable the preview features in Java 19, and then also to add the JDK incubator concurrent module. And likewise, in addition to doing that, you'll also need to go ahead and edit the configuration window and make sure you add the same flags here to the VM options portion. You can add the VM options portion by adding VM options through the GUI. So let's assume we've set all those things up. Now we make ourselves a new shutdown on failure object, which is stored here in this scope variable. The next thing we're going to do inside this try with resources block is we're going to allocate a new list of futures to images. And then we're going to walk through the URL list, and we're going to use the scope fork method to go ahead and start a virtual thread to download each image. And you can see here the way we do this is we're going to call file and netutils download image. And what that does is just turn around and download the content, which just opens a connection to that server and then downloads the image chunk by chunk. So this particular call is an IO bound call. It's demonstrating that you can use the structured concurrency model with lightweight virtual threads for IO bound operations, as we see here. And the result of this is going to be a future to a file, basically, which will occur a future to an image, which will occur when we download that image. And we add that to the downloaded images list. Now, the next thing that happens is we're going to go ahead and call the join method on this particular scope. And we kind of wrap it around with a little helper method to deal with checked exceptions, which are silly in Java. I don't know why they perpetuated that botch, but whatever, that's what they do. So we can get around that by using a little adapter method that turns a checked exception into a runtime exception, which is cleaner. And the gist of this is that join will not return until all of these forked virtual threads finish. And when they're finished, hopefully everything worked correctly. And then we go ahead and return downloaded images. So downloaded images, as you can see here, is basically going to be this list of futures to images. We're now going to take that list of futures to images and call transform images, passing in the downloaded images list of futures to images. Now, by this point, all those images will have been downloaded because we wouldn't have gotten past the try with resources block had that not completed successfully. So we're going to transform the images. As you can see here, we take this list of image futures, which are actually images, and then we go ahead and set up another scope. This is another scope. It's not a nested scope, it's just another scope. And we're going to go ahead and create a structured task scope, shutdown on failure, inside the try with the resources block. Now we're going to make a list of transformed images, which is an array list of futures to images. We're going to iterate through the downloaded images, and for each downloaded image, we're going to call the transform image method with the scope parameter, which is, again, this thing we're going to use to fork a virtual thread, and the results of that image future, which we know has completed by that point. So we can use the new result now method on the future interface. We'll take a look at transform image in a moment, but what it returns is essentially a list of transform images, which we add to our transformed images lists using the add all method, which adds all the various transform images. And let's see why we need to add multiple things here. And that's because transform image takes in this scope. Let's change this thing because it's not really an executor anymore, but instead let's call it scope. It's a better name for it. And so we're going to go ahead and take the scope and the image. We're going to make a transform image futures list. And then we're going to iterate through all the transforms. And we've got several different transforms that we have here. Transforms we've got are basically the grayscale transform, the tint transform, and the sepia transform. So we iterate through each of those, and we go ahead and fork off another virtual thread to transform that image. And transform will simply go ahead and apply the image transform to the image, which will create a transformed image, and that will get added to the transformed image futures local variable. And after this loop is done, we go ahead and return the transformed image futures back to the caller. Now, at this point, those calls may still be running. So notice that we add them to the transform images list, but then we call the scope join method like we had done in the download images helper method earlier, and that will essentially wait for all the asynchronous computations to finish running or finish running concurrently. So when we're all done there, we'll end up with a list of transformed images, and we go ahead and return those transformed images back to a local variable called transformed images. The final thing we're going to do here from a computation point of view is we're going to call the store images helper method, passing in the transformed images. So remember, those transformed images are images that have now been transformed into essentially the transformed or filtered images. We call store images, and store images will once again use a new structured task scope shutdown on failure object. It'll create a list of futures to files. And now what we're going to do is we're going to walk through all the transformed images, and we're going to fork off yet another virtual thread, which will this time go ahead and store the image. So the images will be stored on the local file system. That will end up returning a future to the stored file. It's in the process of being stored, and that'll go into this stored files list. And once again, we use the join method on the scope parameter, or the scope resource rather, that came with try with resources, in order to go ahead and store those results, block until all the concurrent tasks complete. So we don't get any further until everything's done. We then go ahead and return the stored files here. So the last thing we're going to do is take the results, which now are a list of stored images, even though they're futures to files, they're essentially completed, and we're going to go ahead and print the results out. So that is the structured concurrency implementation. Let's go ahead and take a look at the hybrid structured concurrency test. And this is going to use a slightly different approach here. In particular, it's going to use the executor's new virtual thread per task executor factor method, which when called, when you submit a task to it, will create a new virtual thread for each task. And also, just for kicks, I decided to combine the structured concurrency features with modern Java features, in particular, Java sequential streams, which is why I call it a hybrid solution. I cannot stand to write traditional Java 7 code anymore, so I try as much as possible not to do it. And here's how I kind of bridge these paradigms together. The overall structure of the run method here is the same. We download the images, get back a list of futures to downloaded images that have completed. We then transform the images, ending up with a transformed images list of completed transformations on the images. And the last thing we do is we then store everything and we get a list of completed futures that we can then print the size out. So let's take a look at each of these methods, and you'll see that they are similar but ever so different because they're using the executor framework approach instead of using the structured task scope approach. So here we can go ahead and define ourselves a new executor service executor, which is going to be initialized with a new virtual thread per task executor. And so we get one of these things, and then we take our URL list, we turn it into a stream of URLs, and then we go ahead and submit each of these URLs using the file and netutils download image method that we looked at just a bit earlier. And this will end up, as you can see, with a stream of futures to images, which we collect into a list. And the scope here will not exit, will not return a value until all the threads, these are the concurrent virtual threads, complete here. So by the time we exit, everything will be done. So we get back this list of futures to images that are complete. Let's now go down and take a look at transform images, which also uses the same approach. It has an executor that creates a new virtual thread per task executor using the executor's utility class. In this case, we take the downloaded images, turn them into a stream, do a sequential stream, and then we call the transform image method to go ahead and pass the results in here. And again, we can either do things kind of this old school way using the kind of exception laundering approach, or we can use the newer approach, which uses result now, which I think is actually kind of cleaner. So let's go ahead and do that. So we get ourselves the results here without having to do all kinds of weird exception laundering to deal with the crazy checked exception stuff that comes with Java futures. So once again, we end up with returning a list of transformed images. You can see transform image essentially looks pretty much the same as before, except this time, instead of using a scope and a structured task scope, we use the executor framework to submit this particular task, which of course runs in a virtual thread. So once again, we end up with a list here, and that goes back to the caller. And then the final method here is store images, which takes a list of futures to transformed images. And we'll once again use the executor framework, just like we'd seen before, except this time we're going to go ahead and submit something that will store the results. And as before, we can do this using the new and improved result now method. Result now is something that was added to Java Future in modern versions of Java, very, very modern versions of Java. And so you can see how we can convert those things and get the results back in a way that makes sense. So we end up with a list of futures to files, which again, we don't exit until everything is finished and all the virtual threads have completed. So that's basically this implementation. Hopefully you get an appreciation for a couple of different ways to do modern Java and modern Java's structured concurrency. One of the approaches used the enhancements to the executor framework and the new virtual thread per task executor. The other used this new class that we saw called structured task scope, in this case, shutdown on failure. Both of these approaches, as we'll see, they work. They, at least in theory, don't have some of the, quote, complexities of the async approaches and the reactive approaches. I personally think this is way too much code to have to write relative to the other approaches. But we're going to look at the other approaches in the next couple of parts in this lesson.